Hi, I'm Sean Gannon, and this is Minute Math. And we have a math problem here. We want to have a circle, and we want to find the radius. We're given some information about this circle. We know that AB is perpendicular to DE. DF has a length of 12, FE has a length of 4, and FB has a length of 6, as you can see in this image. With just that information, we need to figure out what the radius of the circle is. So I want you to pause this video and see if you can figure out what the radius of this circle is and really how you got there. Now, if you have a different method of getting there than I get, well, great, and let me know down in the comment section below what you did. But if you just want to watch me solve it and learn, we're gonna dive on in. What I want to use here first is the chords theorem. Chords theorem here basically says if I have two intersecting chords as such, A, B, C, D, we use this a lot here, then these two chords, A times a B, is equal to a C times a D. And we're going to use that to find the value of AF, that length right here. So following along, let's say AF is our A, so AF times a B value, which would be 6 here, is equal to 12, the length of DF, times the length of FE, which is 4. Solve for AF. We had AF by itself. We divide both sides by 6. Do it quickly here. 6 and 12 become a 2. It's easy. We get an 8. And so AF has a length of 8 here. All right? Not too bad. AF, a length of 8. Now, what else we have here is another theorem involving, well, chords and a radius. All right, so I'm gonna draw actually a line straight down from our center of the circle, the radius here, straight down, so it's perpendicular to AB. And I'm gonna continue it all the way down here to the bottom, okay? Let's call this point P, right here, point P. Well, the chords perpendicular to a radius theorem tells us, all right, perpendicular here, perpendicular, tells us that this radius splits the chord AB directly in half, okay? So how does that help us here? Well, what's the overall length of AB here? AB has a length of 8 plus 6. 8 plus 6 is a 14, meaning from our chords theorem, from the radius intersecting the chords theorem, that AP should be equal to PB, which is equal to half of 14, right? The overall length is 14, cut that in half, and we get a 7. And so right here, the length of AP is equal to 7. We're working our way through 7 here, and same with PB is also equal 7. I'm not gonna write that down here. Okay, as you can see, we're getting kind of close to maybe creating a triangle. Good idea. But I'm gonna actually do the same exact thing with the second chord. So again, I'm gonna make a radius that is perpendicular to chord DE across the line right here. It's perpendicular, okay? Going through this intersection, A, B, C, D, P, what did I call it? I call it N. Point N, that intersection here, and we're gonna do the same thing. Remember, it cuts the chord directly in half, all right? Cuts the chord directly in half. So the length of DE, let's go up it here, DE, same idea. That overall length is 12 plus 4, which is equal to a 16. So the length of DN is equal to the length of NE, which is equal to the length of half of 16, which is an 8. So we have an 8 here for DN. We just want to put it there, we can. And NE also has a length of 8. All right, what else information can we find? Sometimes I like to just go find what I can here. Well, if the length of AF was 8, and the length of AN is, AP is 7, PF is a 1. Put that here, let's just get that information. PF is equal to a 1, which is equal to CN. right? Because we got a rectangle going on in here. Opposite sides are congruent, so it is equal to Cn. Same idea, can we find the length of NF? What is NF equal to? Well, that length here is, well, we found out before that this little length was 4, this big length here from DF was 12, DN was 8, 12 minus 8 gives me the length of NF, and 12 minus an 8 gives me a good old 4. So we have a 4 here, right? So this length is 8, we have 12 overall, get a 4. That means it's also equal to CP, which is also equal to 4. And hopefully now you can see we got a right angle right here. We're gonna be using good old Pythagorean theorem. We make a little radius right here, connecting A to point C, and that is our hypotenuse. We wanna figure out what that is. That's our R, right? Our radius. So we can apply the Pythagorean theorem here. We have a 4 squared, the first leg, plus the second leg squared, 7 squared is equal to the radius or hypotenuse squared, right? Then 4 squared, 16, plus 7 squared is a 49, equals an R squared, right there. 16 plus 49 is a 65, equals R squared, meaning that our radius R is equal to, we square root both sides here, square root of 65 units, or approximately the decimal is 8.06226 for my notes, right there. But there we got it. I like this square root of 65 better, and that is our radius of the circle. Did you use this method to solve this problem and get the radius? If you did, great. If you learned something, that's also great. If you use a different method, let me know down in the comment section below. I always like to figure out different ways to solve this problem. I hope you liked this video. If you did, like this video, subscribe to our YouTube channel. This helps us make more of these fun math videos for you and for everyone else. So, as always here, thanks for watching.